My name is Ubomo Endurance Osas. As part of this course requirements, instrumentation and control of energy systems, I'll be making a presentation that is titled The Design of Hybrid Renewable Energy Systems with Battery for an Off-Grid Rural Communities. Professor Jermaine, thank you for this opportunity and thanks for the wonderful classes so far. This presentation will be categorized into various parts, which include the introduction, the significance of these research projects, the problem statement, methodology, proposed system schematic, MATLAB simulation and the results, the conclusion, distribution of papers used for this research and design, and the comparative criteria for the papers that were used. On the right side, we also show you a pictorial view of a typical hybrid energy systems that is used in these projects. From our introduction, we noticed that using hybrid energy systems in power generation is an economic alternative when power grid extensions are not an option. Several local renewable energy resources are combined with or without conventional fossil fuel resources to create a standalone system that can meet the energy needs of rural remote communities. These include the use of biogas, biomass, solar, wind, and small hydropower. But for the sake of this project, my scope is based on the use of solar, wind, and diesel generator. The significance of this research and design. In developing countries, rural communities lack affordable, reliable, and sustainable forms of energy, which is an essential thing you need in improving living condition. Because when there is power systems that is functional and a constant supply of power, there's going to be a lot of growth in different sectors of the economics. This makes this project to be very significant, especially in the rural communities that sometimes lack affordable power supplies. And also it will also help to reduce emission, because when you depend on fossil fuel totally, there's going to be a lot of emission. But with the use of renewable energy, it has cut down emission to the least minimum. From the problem statement of this project, we notice this project is specifically designed because of the off-grid communities, whereby the use of power grids is not an option because they don't have access to the grid. Thereby, this particular system that is designed is such a system that can integrate renewable energy sources like the solar, the wind energy, and the storage system as well to ensure reliable and uninterrupted power supply. The design should optimize the system overall performance, include energy generation, storage, and distribution, considering the load requirements and the intermittency of renewable resources. From the methodology, we could see that this system is designed in such a way that there will be a controlled algorithm to optimize the operation of the distributed energy resources system to ensure efficient energy production, efficient energy storage, and utilization of this energy. This may include maximum power point tracking algorithm, the voltage and frequency regulation, and energy management strategy. Also, the system simulation analysis will be fully conducted with the use of MATLAB Simulink to evaluate the performance of the distributed energy resources system under different operating conditions such as varying solar and wind condition, load fluctuation, battery charge and discharge scenarios. Finally, the simulation results shall be evaluated to assess the system performance metric, which include the energy generation, the storage efficiency, the power quality, as well as the grid independence. To achieve this proposed system I have worked on, I have designed, I actually started by using OMAS software to carry out some analysis and design of the schematic and to run the system to ensure the system is very efficient in terms of the costs. So you can see below the picture of the OMA design system schematic, which shows a generator, a wind turbine, the total load that you are to power, and we have the converter as well as the wind, the what's it called, the photovoltaic module, which is also known as the solar panel, and the battery that will be utilized for storage. And after running the system through the OMA, You can see the system architecture, which consists of what I just listed: the generator, the PV, the storage system, the system converter, and the display. And also, you'll be able to see the system converter electrical summary from Oman's software. This is just an extract from the software, although the design is more than this on the software, but this is just to give you a pictorial view of what is expected in this system, as my concentration is mainly on the MATLAB simulation and not the HOMA. The HOMA is just to aid me to be able to carry out the initial phase of the design. Below is the MATLAB Simulink simulation. It shows various blocks of how the wind, how the solar PV, and the generators are all interconnected together, and you can see various scopes that are highlighted green, so that those scopes are where you get the outputs of whatever is going into it. So this is the simulation of the system, and below we are also going to talk more about the outputs via the various graph that is being plotted from this system, so we can understand the behavior of this particular system. Okay, from the MATLAB Simulink simulation, the following results we are getting. Some of the outputs include the solar irradiance, the output power of the PV, as well as the state of charge, and the battery current, and also the state of charge, and as well as the output DC bus voltage in this particular simulation. More of this information can be seen in the native file, but because of this presentation, I just decided to put a summary of the result in this place. We'll also go further to the next page to see further output from this particular simulation. Part of the simulation result continuation shows us the load current and the load power, which is also rated in watts, and the curve, and to see the behavior of this load current and the load power of this particular simulation. So also, because we are using a generator, there is need to also see the rectified diesel generator outputs. So this graph shows the rectified diesel generator outputs for the system as seen from the MATLAB simulation. In the conclusion, and from the analysis run with both the HOMA and MATLAB Simulink simulation, I have come to a conclusion that the system was simulated under varying solar irradiance, and the result was observed using scopes, which we were able to generate our charts and graphs from. Our various plots were gotten from the scope, and the MPPT algorithm worked to keep the voltage at its MPPT for a varying irradiance value, and the maximum power was extracted from the PV. The DC-DC buck converter decreases the voltage to the required level with a higher output current, and the results also shown that the battery storage system absorbed excess energy during periods of high energy production and gave out energy during period of low or no energy production. That is the purpose of that storage there. And also the diesel generator injected a predetermined constant power into the system to supply the load and charge the battery during the period of no solar irradiance and low power state of charge. The state of charge for which the battery is cut off and the generator kick in is 45%. This study system showed a satisfactory response and can provide stable power to the load for the off-grid location under consideration. Below are the distribution of papers that were consulted during this particular project work. These are the category of journals that were used for this work, and it's being showed on the pie chart to show the distribution of the paper. This pie chart further shows the distribution of the papers, the various aspects of journals that were consulted, and the percentage of journals that were used in different aspects. Some of these journals were directly used in this work, while others were studied for knowledge sake as it concerns this particular presentation and the project in general. These are some of the references that we are using this particular work for the sake of space.